Welcome to Landwards, the podcast for the land-based engineering community, brought to you by the Institution of Agricultural Engineers.
Hello and welcome to Landwards, the podcast of the Institution of Agricultural Engineers. I'm your host for today, Andy Newbold, and I am joined today by Charlie Nicklin, the Chief Executive Officer of the institution. Hello, Charlie.
Good morning, Andy. How are you?
I'm very well, thank you. I was going to say better than the weather, but it's unseasonably warm today on the 9th of October. And although it's still misty here in the north, it's probably about 19 degrees already. So Indian summer, possibly. Anyway, how are you doing, Charlie?
Yeah, good. Yeah, it was certainly warm yesterday.
Yeah, so
it was like a summer's day.
It's fooling us because, according to my sources in the Daily Mail or equivalent, we're going to have a cold, hard winter. So today's podcast, we're going to talk about trends in agricultural engineering, specifically looking at the end product of machinery. And the inspiration for this was the DLG, who organise Agritechnica, have put out quite a lot of press releases and news recently regarding technology and things which are on show. But one particular document looks at trends in agricultural engineering, and it's a very good primer for where the tech is going. And, you know, we quite enjoy talking about that, don't we, Charlie? So we thought we'd make a start. So, Charlie, let's go with a few headlines. What do we think are the drivers on the trends in changes in ag engineering?
I think it's what we've seen for the last few years, really. Obviously, this focus, there's always been a focus on efficiency and productivity in agriculture, and that's continuing. And obviously now we've got this extra dimension in there, which is the climate, reducing our carbon footprint. So everything sort of relates to this, being better for the environment, but doing things much more efficiently. It's just carried on that theme.
Yeah, I think, the subtext would be, it's always been bigger, harder, faster, better, more.
Yeah.
And now, particularly, Europe's stated objective is to reduce ag chem use, for instance, by 50%. Embedded carbon in energy, be that fertilizer, fuel, resource efficiency is coming to the fore, and society demands it.
Bigger, better, faster, and be kind to the environment.
Yes, as you say, it's moving on, and at the end of the day, what we come up with as engineers has to reflect society's needs and wants, and that's where we are. It's quite an interesting discussion. There's an awful lot of embedded carbon in fertilizer. Fertilizer is basically produced generally by the Haber-Bosch process, which takes an awful lot of gas. Which gas has been in the headlines for the last few years for obvious political reasons. So the nuts and bolts of that for farmers is use the right stuff in the right place at the right time. So how does that play out in the field then, Charlie?
Well, I think, if you look at things like sprayers, they've had things like variable rate and section control and that sort of stuff on, for a good number of years. And, we have variable rate systems on fertilizer spreaders, but the granulated products probably not received the same amount of focus. And Amazon have shown some new technology, starting to introduce things like, curve control. So when you're going around the outside of a field or on a bend, it can reduce the amount of product going on the inside and speed up the stuff that's going on the outside, and being a lot more precise in the application of what is a very expensive commodity these days,
Yeah.
So why shouldn't we put it on very accurately where you need it? It's that sort of technology. It's really interesting being applied to the granulated products. And also, we've seen things going into the application of manure, liquid and solid manure, because that as well is a very important commodity that is put onto the land to produce crops, and that needs to be carefully managed as well. You don't want excess slurry in some areas leading to runoff, and likewise, you don't want to underdose other areas. So again, why shouldn't it be treated accurately and precisely?
And I think there's quite a lot of technology starting to come to the fore now. with, we're applying on the basis of need. So, overlaying soil maps and application maps, a couple of products spring to mind. In fact, speaking of products springing to mind, John Deere's Harvest Lab technology, which they've had on the forage harvesters for a long time, is being used in slurry application now so that they can real time vary the rate of slurry on the basis of what the soil requires. And I see that Zunhammer have just got a Agritechnica silver medal for their section control for their boom applicator, which effectively means they can vary the rates. I think they have a twin pump set up with each side of the boom on the slurry tanker to vary it to need and vary it to produce application maps of as applied slurry. So it's I was about to use the phrase trickling, which is probably inappropriate, but the technology, which has started in various areas, is being applied across the board now to, liquid slurry, fertilizer, be it solid or liquid, as well as AgChem, where an awful lot of this started. The other thing which is worth mentioning as well is there's a lot of emphasis now with seed drill manufacturers on placing fertilizer alongside or adjacent or under or over the seed which has been placed. So we're seeing it in drilling and sowing, with fertilizer being band applied, fertilizer being spot applied, very much good old fashioned combi drilling, as we would say in Scotland. So it's moving, fertilization technology is moving out of specific application, as a field activity in its own right, to being bundled with seed planting.
Yeah, people have perhaps forgotten what a combine drill is. If you said combine drill to people now, they probably wouldn't realise, would they? But it was that whole thing of a combined drilling and application of fertilizer, But it's I suppose the other thing with drilling is that the days of the old fashioned drills for drilling barley, wheat, rate and that sort of stuff. There's a lot more people moving to precise drilling of those types of seeds as well now. And it's this whole theme of being much more precise. And also where you seeding multiple crops at the same time is an interesting one,
Yeah, and so we've got drills now, and we're starting to see what's come out of the precision drilling world into singulation and single seed application materials. So you're getting equivalent yields with much less seed, because historically a seed drill had a set of fluted rollers. And effectively, you change your seed rate by speeding up or speeding down that fluted roller, which each movement of that fluted roller gave X number of grains. Yeah. Whereas something like Vadistat Seedeye, for instance, but other manufacturing products are available. That is choosing a single seed, holding that seed onto a seed wheel with a vacuum or equivalent, and dropping it down the slot. And that tech is becoming broadacre specific now as well, rather than, saving it for maize, saving it for sunflower, saving it for pumpkin, saving it for vegetables. We're now seeing that for broadacre cereal crops. And, much greater, more precise per coulter control of seeding depth and consolidation of soil around the seed.
Yeah. And I think so, and if you're looking at, where you've got no-till and min-till techniques, it is much more important, isn't it, now that the coulter arrangement has got to have a precise control of how deep it plants that seed in a surface that's going to be variable. You're going to have hard patches, you're going to have soft patches, but the seed still needs to go at the right depth where the moisture is, and so it's there's some clever bits of kit on the market. Yeah.
Well, we're moving from per field, as in let's turn it all into a homogeneous recipient matter, i.e. soil, which has all been worked to. Just working the strip or the line, which in the case of a strip till machine, where that tiny little bit of soil where the seed goes, or in a direct drilling case, cutting a slot, using a knife coulter as a chisel to open something, pushing the seed in and folding it back against it. So the germination of that seed becomes much more critical because there's much less seed around, and it's not in a uniformly it's not effectively broadcast or spread or planted across a uniform open soil. It's now going in a very specific area, which may or may not have had a degree of cultivation. Yeah. So, and yes, you can use a lot less seed, but it does become much more critical, which of course is where the technology comes in. We've talked about fertilizer, we've talked about drilling and sowing. What about crop protection? Again, going back to this 50% reduction in active ingredients. What are we seeing, Charlie?
Well, I think the end of the day, the goal has got to be to completely get rid of chemicals, hasn't it? And we're probably a long way off that, but certainly reducing chemical use. I mean, chemicals are really expensive products, and they need to be, again, used precisely in the right place at the right time. There's been various developments going on with spot spraying and different types of nozzle control. Again, we talked about fertilizer, where you want, if you're going around a bend, you need to put more product on the outside of the bend than the inside. And obviously we've seen that with sprayers now, where, if you're turning, the sprayers can even change nozzles automatically to bang on more product on the outside of the sweep and almost stop the chemical coming out on the inside as you turn, and section control and that sort of stuff. But it's sort of coming, back to individual nozzle control now. And again, it's all driven to try and reduce and make the use of chemicals very, very efficient. And there's a carbon footprint associated to chemicals, isn't there? In the manufacturing of chemicals.
Oh, absolutely. Yeah. And I think the ag chem industry works very much on the basis of responsible use, and there are tasks ag chem can achieve which is difficult to replicate with mechanical means. Having said that, we have seen a massive growth in mechanical weed control. So, camera guided hose with carriages to attach to the tractor with a side shift linked to GPS and all linked to cameras. Tractor operating in RTK, so it's driving in a straight line. And we're seeing this for high value crops like vegetables, and we're seeing it for, maize before it gets too tall and sugar beet, things like that. But we're also seeing it in cereals as well. And there's been an explosion, and most mainstream cultivation manufacturers are now in mechanical weed control.
Yeah. And I think also with the weed control, it's a natural area for autonomous vehicles. If people are thinking about where we're going to use robots on farms, well, robot weeding machines, it's an ideal thing, really. Just to have there's plenty working in the UK, mechanical weeding robots just going up and down rows, doing mechanical weeding, and it's probably, it's a great idea, really, and you can certainly see more of that happening.
And the labour challenge is not going away. People don't want to sit on tractors. People certainly don't want to walk up and down a field hand roguing blackgrass or with a hoe knocking things out in rows between sugar beet. That world has moved on. So we're looking to engineers, we're looking to supply chains to give us solutions. And ag chem has been a very strong part of that solution, but the technology is moving on. So I know, speaking of technology moving on, it's probably sensible at this point to talk about tractors, which, whilst it gets everybody terribly excited, and we have talked about this at length before, the CO2 problem, the emissions problem, is writ large in tractor development, isn't it?
Oh yeah, absolutely. I mean, that the tractor industry have never had this dilemma before. Of we've said it before, from 50 to 500 horsepower, it's always been diesel all the way, and now it's not going to be that. It's going to be, probably electric up to a certain power. We're seeing a few introductions to the market of tractors sort of 50, 60, 100 kilowatts. Which I would imagine are
have got an electric Vario, E100 Vario coming out.
And I'd love to know what sort of money it's costing for batteries. Because I know a kilowatt of battery power a few years ago was £500 a kilowatt. Well, 100 kilowatt, then start working out, do the maths. It's 50,000 batteries. So surely, and I don't know, I've not been close enough to it now to understand what are OEMs paying for battery power, but that's a key area, and it doesn't seem to get talked about much, but in the automotive circles either. But so this engine dilemma they've got, is really, there's some really different thinking out there. There's people, looking at fuel cell machines, although that's in its infancy in the ag world. There's plenty of people messing around with hydrogen combustion. There is the activity that's going on in the New Holland world on methane and liquefied natural gas.
Yeah.
With the T6s and T7 tractors, that's really interesting. There's so much development around engines, it's incredible. But I think the IC engine, the combustion engine, will live for a long time yet. That's going nowhere. You can tell that the companies are still introducing new engines to market. The buzzword is agnostic, fuel agnostic engine, where they can be simply
HVO.
Yeah, HVO.
So recycled hydrocarbon fuels.
Yeah, absolutely.
Diesel analogous.
Yeah, and a lot of these fuels, yes, they could make the fuel renewable, but then you've still got to clean up the stuff that's coming out of the exhaust. So it's not all rosy. Even burning hydrogen, you've got to control nitrous oxides, which we can do already on diesel engines, so it's no drama. But they've all got their challenges. And then transmissions have not been forgotten, because obviously the transmission plays an awful big role in this. A tractor, what is a tractor? Well, it's a gearbox on wheels, isn't it, to put tractive power down? And so the transmission is very important, and there's still lots of developments going on around drivetrains, people looking at electric drives, Fendt rolling out their Vario drive, where they've got the sort of almost two transmissions, one for the front axle, one for the rear axle. That's getting down onto the 600 tractors now, so that's interesting. A lot of development around engines and gearboxes, which is pretty much what a tractor is. It's an engine and gearbox with a cab on the top, isn't it? So yeah.
No, and I think, we're seeing a stratification, aren't we? Light duty can go electric. Yeah. Anything above light duty needs something else. New Holland's new T7, the LNG one, they've done something with the tank to store the natural gas at very, very low temperature. So it's liquid.
Yeah.
And they reckon that tank can hold, that tractor's fuel capacity is 8 times as much as the T6 180 methane equivalent, where it holds it at an ambient temperature, because the low temperature compresses it so much.
And that's obviously the issue with anybody who knows anything about gas is the density compared to diesel. A fifth. So you need to get the same amount of gas on as you've got diesel, you need 5 times the storage, which is just bonkers.
If you remember the first ever New Holland methane tractors, they had tanks built up the arms of the cabs. They didn't look anything like any other tractor, because they had basically lots and lots and lots of little methane tanks all for them, just to be able to carry enough fuel.
So LNG does sort of mitigate some of those challenges, but in doing so, you end up with quite a complex storage facility on board, because it's cryogenically stored. So. And I think, they are using LNG on things like trains, where you pretty much got a power station on board, haven't you?
Yeah.
You can see that sort of technology going on larger machines, because I always think, what we're going to do with things like combines, where it's an occasional machine that's used for a month and a half in the year, if that these days.
150, 200 engine hours a year tops.
And you've got this hideously expensive power plant now on board to power it. Is that the best way of doing it? Is there another way? It's a real big dilemma. Engines, a combine engine is an engine that's used into other machines as well. It's known technology. It's got economies of scale. All of a sudden now, it's going to have this bespoke power plant on there.
I think extension cables and electric converters is the answer, Charlie. You've just got to remember which way to turn on the headland, so you don't pick it up on your table.
Maybe we'll go back to PTO-driven combines that you pull behind.
You heard it here first. PTO-driven combines. I quite fancy, and in fact, I could do one at home if anyone's got one. One of those old JF wraparound combines to go on with David Brown 990. I always liked that. I liked the idea, like a trail combine, because you're utilising your power source. I always thought it was a great idea. But obviously that's not the way we're going at the moment. So
no.
My apologies to anyone else who got very, very excited about that as well. But moving seamlessly onto combines as we are, New Holland got the only Agritechnica gold this year for their CX twin axial rotor combine. And the interesting thing about this combine was they recognised that there is a cross section of physical dimension which can be used for combines because of road widths for legal reasons. And they recognise that the existing engine positions in combines often precluded space which could be filled with threshing technology. So they've moved the engine on the twin rotor. So the twin rotor with a pair of axial flow rotors runs from low down at the front as you look side on to high at the back, and they've effectively relocated the engine to the back to be able to drive those rotors from the back, as far as I'm aware. But what that's done is it's enabled larger rotors to be within that cross section without exceeding the maximum working width. Sorry, not maximum working width, maximum road width of the combine. So a deceptively simple answer, which I dare say has taken an awful lot of engineering to make it work in practice because of weight distribution and things like that. But in terms of combines, engines is a problem. What else do we need to think about, Charlie, with harvesting technology?
I think with the combines, it just, everybody thinks, can machinery get any bigger? And every year it gets bigger and bigger. And combines are a challenge. I mean, if you're a combine designer, you've got this big rectangular box that you've got to fit everything in that has to fit down the road, and then you put the biggest header on that you can imagine that you can tow behind something. That's what combines are now, a big rectangular box with a massive, what looks like two headers from years ago on the front, and the productivity is incredible from these machines now. And I don't know where they'll go with it, because you go wider than 45, 50 foot now? Surely it's getting sort of...
It's the limits of practicality, because it's...
I suppose the bit that makes me laugh these days is that, the fact you've got this combine now with a 45-foot header on the front is every time the header gets bigger, so does the unloading spout. And the unloading spouts look so complex now on these combines. They're massive in diameter because of the throughput you've got to get through it. So the weight must be incredible when you've got that thing half full of cereal crop, going through into the trailer. And it has to be so long so the tractor can get around the header. And it just makes no sense to me that...
and it needs a very, very, very strong turret to hold that.
There must be a better way of unloading the combine now than... I mean, obviously, unloading at the back, you've got the carting tractors in all the dust and debris coming out the back end. So it's a tricky one, but the size of the unloading augers is phenomenal now, and that they have to fold round the back so you can go down the road with the thing, But
I mean, the other, just while we're talking about combine harvesters, you'll have seen the Nexat, Charlie, which is this sort of German developed product, which seems to be happily working away on very, very, very large farms in Brazil. And Eastern Europe in various places. Now, the Nexat is, for those of us of a certain age, the development on what we would have called a gantry tractor. But I think it's about 12 or 14 meters wide with a pair of power plants and interchangeable equipment between it, be they soil working, crop protection, drilling, or indeed harvesting. They have their own purpose-built sort of harvesting unit with a Geringhoff header on. I think it'll be a while before we see a Nexat in Cumbria, I must admit, but it has its place. And they have got numerous units out at work, and I'm presuming that it's for sale. I mean, if we go to Agritechnica next month, we'll be able to go and have a chat with them and see. But that is just, a mind-blowing take on something we saw in the 80s and 90s as a piece of experimental work around reducing soil damage. Where technology has caught up and they're bolting existing technology onto something to do, it's one power unit, it's used for everything. Yes, it's probably a very expensive power unit, but equally, you need nothing else on the farm other than something to take your grain away with.
Yeah. I mean, the gantry thing has been around for a while, hasn't it? I say, we all got that pushed down our throats years ago. That's the future, and it's never happened. But it's like the some of the robotic autonomous machines are a sort of gantry style arrangement. This is an interesting theory. I don't know. It's a tricky one, isn't it, with combines? There's a lot. When I describe combines to people who don't really understand them, I'll just say it's basically a factory on wheels.
Yeah,
it's a processing factory going down the field, isn't it?
Well, that's a very neat link, actually, Charlie. To be honest, when we talk about processing factories going down fields on wheels, let's talk about harvesting potatoes, and within the context of work rate and quality, particularly. Once upon a time, we all stood on the back of a potato harvester and picked clods and green bits off, didn't we?
Yeah. Yeah, absolutely. Yeah, I mean, this whole sort of development around cameras and sensors and whatnot, it's making its way into this type of equipment, isn't it? So, yeah,
a lot of in-field separation is now happening with sensing and with a selection of products which can physically separate damaged potatoes or stones or anything else out, so that the first clean has been done before it gets to the store. And on the same basis, looking at the drive to eliminate in the case of haulm desiccation, I'm guessing acid or other products. We've got things like flame weeders and electrocution, so electric haulm desiccation, which is becoming available so that you can knock the top off the taties without using an active ingredient. I guess a thermal flame weeder is probably using some carbon somewhere. So maybe that's not quite as good as physical termination or electrocution, but equally, these are great ways to take physically nasty products which hurt people, let alone the carbon footprint, and make the process a bit easier. And again, you talk about sugar beet harvesters. The default is a 6-row self-propelled sugar beet harvester with a tank on nowadays. They're designed to go on the land when you shouldn't really go on the land in a lot of cases. There's a great deal of potential for damage in the soil with a sugar beet harvester. So a lot of the focuses now are on, lighter footprint, spreading the weight, tracks, wider tyres, and service life and things like that with the use of telemetry, which again, these systems have come off combine harvesters and forage harvesters, and things like integrated weighing. The same drive, greater precision, greater, resource efficiency is applying across the board, isn't it?
Yeah. I mean, they're big machines, aren't they? They're big, expensive pieces of equipment. And as you just said, they're always on the ground when they shouldn't be. It's all wet harvesting sugar beet, and they are large contractors' machines. And so that telemetry support and all the stuff I've got there is essential, isn't it, for contract? These machines need to, because of the cost of them, they need to be working hard, and being efficient. And I mean,
moving on to grass harvest, there's a lot going on now with sort of RFIDing of bales, and things like that. I'm going to stop this at this point, Charlie, and just say, can you hear that printer in the background?
I can't know.
That's fine, because there is a printer going hell for leather about a yard away from me, the office printer, because Anne's obviously sent some huge document to print. And I'm a bit worried about the recording, but I'll dive in, and we'll say it's about 30 mins in. It's okay, don't worry, Anne, please don't print anything else. She's just printed the Old Testament out on the printer, Charlie. Well, I'll tell you when I'm done. But we will carry on talking about feed harvesting technology. Now my work group printer has just interrupted and autonomously started printing something. We again, the same's applying. We're seeing sensing, we're seeing yield mapping, automatic RFIDing of bales, which is logging things like moisture content, which is particularly useful for forage as well as for power stations. And trying to get the same dry matter out of a bale with different bale pressures and different bale diameters from variable bale chambers. So all this tech is being applied across the board. I noticed that Fendt picked up a silver medal from Agritechnica this year, a silver innovation medal, because they've got an automatic mower conditioner adjustment with a sensor looking at the grass, deciding how dense it is and how much conditioning it needs. And then it's got a baffle plate which automatically adjusts against the conditioner. Quite simple, but possibly quite effective, I think.
Yeah. It's it's this technology, this focus on the sort of technology, the monitoring and everything linking up with everything. That you know the inputs going in. We know what's coming off. We know at a precise level, don't we? It's everything's sort of following through all the way. Whether it's forage, whether it's potatoes, whether it's cereal crops.
And I mean, there is the great thing nobody's allowed to talk about in terms of forage conservation, which is that we all insist on making thousands and thousands and thousands of big black eggs every year and wrapping them in plastic, which if ever there was a source of, embedded CO2 and embedded carbon and embedded oil, that's it. The alternative is clamp silage, but a lot of farmers are not set up for clamp silage, and that requires different technologies. So there is a challenge ahead in terms of, recycling plastics, using those plastics for other things, ways of conserving grass at optimum nutritional content, which you would argue haylage probably is, and silage certainly is, in comparison to hay, which is still resilient for making the crop, i.e. you can get it when it's green, and for storing it. Because, if you make a round bale of silage and don't seal it, it just goes off.
Yeah, absolutely. Yeah.
So there's a big challenge for engineers and scientists out there, and I'm sure the manufacturers are working on this very hard about how we A, wrap with less plastic, or B, find alternatives or recycle those plastics back into the chain to use those plastics again. I'm not an expert on this at all.
No. I mean, it has become the norm, hasn't it? Round bale silage and square bale. Just seems. Years ago it was all clamped, wasn't it? Yet we still, all maize is still clamped.
Yeah. There's things like the ag bag, etc., which
they've never really taken off, have they? You do see them occasionally, don't you? But I drive up the road from here, and there's the biggest stack of black wrapped silage bales I've ever seen in my life.
Oh yeah,
it's twice as big as the shed that's got the cattle in. You just think, years ago that would be in a clamp with a big silage with a sheet over the top of it.
Yeah, and I think to move away from plastic, different techniques need to be used, whether it's self-loading wagons, whatever it is. Things are going to have to be done a little bit differently. At the
end of the day, it's the farm should know the cost. But you think about every single one of those bales is wrapped, handled, stacked.
Yeah.
And then you want to use it, you've got to pick every single bale up, unwrap it,
take the net off it.
Is that more cost effective than a clamp full of silage where you have a shear grab and you just grab what you need and
you dump it out and seal the thing? I suspect it probably isn't, but the issue is it's the cost of building that silage clamp, isn't it?
Yeah.
That's the challenge. Is how much it costs to get that silage clamp built.
Yeah, right.
And to move over, and for a lot of relatively small farms who aren't, say, milking cows, but who are happily keeping beef, cattle, and sheep, a round bale is functionally very easy. You just whack it on the back of the tractor and go up the field and dump it.
You'll have to get bigger.
Yeah, that's
bigger bales.
Bigger bales. That's it. Yeah, I think Vermeer have got one in the States, haven't they? They've got this monstrous round bale. I've seen it on YouTube. If you can't sleep at night, the link will be shared, I'm sure.
I mean, you think about it. If you think around what's a round bale of silage weigh versus what you're now handling, because people are not handling it with a tractor loader anymore. Everybody's got a telehandler.
Yeah,
those telehandlers can pick up at least 3 ton. So. Do we need bigger bales? I don't know.
And I'll just say it would get very exciting on some fields in the north, which I happen to with a 2-ton round bale on the back of it.
Round bale.
Yeah, it would be a very fast roll or hurtle to the bottom. We're quite happy with a 450 to 550 kilogram round bale on the front loader. and in some circumstances, that is exciting enough. At the risk of being Mr. Health and Safety for a minute. Another thing is, overlaying all this technology, we've never been in a better position than to monitor and manage, have we? And digital systems and IT are now offering capabilities which we've never seen before. And I think that's worth a brief conversation before we finish, isn't it?
Yeah. I think that, it is this trend towards, cross manufacturer solutions that's been required for years, and all these standalone systems that people keep coming up with don't talk to each other just drives everybody insane. And it's just a case of, systems that can operate across different manufacturers. So you've got, the poor person using it can just use one system and it talks to everything else, and it's exactly what's needed. And I think software design and development is much better than it was years ago, isn't it? Now that they are, systems do tend to talk to each other much better than they did, years ago.
Yeah. No, I'd agree with that, and I think, I was talking with a drill operator in the spring on a farm, and he just said he'd moved over to a new system on his tractor, and he drilled his field in a completely different way from how he used to, because it suggested to him a sequence of working the field which completely optimized his turns and maximized the amount of time the drill was actually engaged in the soil seeding, and minimized the amount of turning time on the headland. He said what actually happened is he lifted the drill out of work at the end and drove out the gate.
Yeah, brilliant.
Which of course is the holy grail. And a skilled drill operator was, well, I'd have worked that one out anyway. But when you've got hundreds of hectares to drill, having a piece of software which knows where you are, knows your field outlines, knows the width of the machine, and can work it all out because it knows those boundaries, is brilliant, because it's taken the pressure off the operator. And it will reduce the amount of fuel used, it will reduce the amount of time used. To me, that's really good. And that overlays to, crop protection products, fertilizer, seed, every single input, or how much time the forage harvester is idling on the headland, waiting for a trailer, or turning on a headland. Because it's that great phrase about it's your own money you're wasting, it's your own carbon you're burning. All of these efficiency trends and technology trends are driving towards the same thing.
Yeah, and you just want that technology to work. That's the thing with it, is you don't need to invest in, if you're a user of a certain brand's tractors and harvesters and your software only works in them, and you want to use a different type of product and the software won't work in it, and things like all the ISO bus connectivity stuff, it just needs to be seamless, doesn't it? Make it easy for the user, the operator.
Interoperability, I think.
Plug and play, and away you go,
Yeah, and I think the longer we go on, the more we see this starting to occur. And I think a lot of the challenges now remain, which are really in the farmer's hands, which is what on earth do I do with all this information? My operations are becoming slicker, but how do I maximize this flood of data, which we never used to have? And like all these things, the devil's in the detail, or the devil is in the decision, because it's giving growers, giving farmers information to make sensible decisions, and trusting that information and trusting the validity of it. It is, and I've said this for decades, it is a very exciting time to be an agricultural engineer. But I think because Agritechnica is here for the first time in 4 years, and they're talking loud at the moment about where the technology is going, it's a really good time to take stock and look and see where things are going, where they've been, and that excitement, despite the fact that I'm, comfortably middle-aged, or according to my children, an old git, that excitement doesn't go away for me, Charlie.
It's the technology is phenomenal. It really is. And if you think, it's 4 years, I think there'll be an absolute explosion of technology at Agritechnica.
Yeah,
because 4 years is a long time in technology. 4 years in computing, 4 years in sensors and all that sort of stuff. Things have moved on just in that short space. It's incredible. It is. There's so much going on. And
I think one of the challenges for manufacturers, for the industry of agricultural engineering, is taking the customers with them. And what I mean by that is, I think there's an awful lot of technology out there which could be greatly beneficial, but the users have to be comfortable using it and understand how to use it, and that's a big challenge.
Yeah, and it's always the case, isn't it? Any new technology, once the farmers see the advantage, it'll just they'll use it. That's the thing.
Yeah, no, I quite agree. Well,
the whole theme is is bigger, better, faster, more, isn't it? Still,
Yeah, of course it is.
Higher work rates, better productivity. That's what agriculture has been like for a century, hasn't it? How do you do?
And our focus, particularly societally, because we've all moved, from an agrarian society where everybody grew their own food to concentrations of population who live in urban conurbations, and the land is still there to be used, but it's been used in different ways.
Yeah.
That drive will continue, and efficiency is still all about the environment, because if you're growing a better crop more consistently with less resource, that's got to be good. We're still, mainstream agriculture and mainstream agricultural production is still heavily reliant on hydrocarbons. To take that step shift, to move away from that, we're starting to see those changes, and that will just continue.
Yeah.
Because the other alternative is to starve, and I think societally we're not too keen on that.
No, I wouldn't have thought so.
So I think, as an ag engineer, it's a great time to be alive. There's big challenges. Those big challenges don't go away, but innovation is there, and innovation of working together to make these things work is a great thing. I think that's probably a decent point to wrap things up, Charlie. What do you reckon?
Yes, I think so. Yeah.
Well, look, thanks ever so much for your time with this. I think we might revisit this when we've been to Agritechnica, and just have a bit of a think about some of the things we've looked at, and maybe reflect afterwards as well. But really, Charlie, sincerely appreciate your input today. It's been great to have a chat about this. It's a great time to be an agriculture engineer. Thank you, Charlie.
No problem. Thank you very much.
You have been listening to Charlie Nicklin, Chief Executive Officer of the Institution of Agricultural Engineers, and myself, your host, Andy Newbold, as Landward's Editor, on today's Landward's News, Agritechnica preview. Call it what you like. We'll catch you soon. Thanks, Charlie.
Thanks. Bye-bye.
Bye-bye.
For more information, visit www. You have been listening to Landwards, the podcast for the land-based engineering community, brought to you by the Institution of Agricultural Engineers.